and use that tool. So what we have done here, right, is to go from the evolution of trading model to LLM is the next step. So agent now is defined as memory, right? We have long-term memory and short-term memory. Tool calling as well as reasoning. And what we think a superhuman trader is LLM orchestrator plus specialist agents. And this is like a very high-level architecture diagram that we have done. Essentially, the orchestrator will orchestrate the intent, as well as you have an agent store specialized in each different market, as well as the tool calling. You have risk, market events, derivative, tech analysis, social mindshare, and then the synthesized agent will do the synthesis. And we're doing this layer by layer. So at the base of everything, we have a data foundation. We're ingesting on-chain, off-chain data, news, tweets, knowledge graph, and also entity registry. And on top of that, we have our agentic layer, right? We have agentic flow, GenUI, personalization. And then on top of that, we have application. We're serving the agents. And then we're servicing that onto our app, as well as TG and Discord. So this is the architecture, and now I will show a demo, a walkthrough of what we have done with our agents. Yeah, and this is probably one of the most important alpha that I can give you guys. And at the end, we'll also give you the sign-up QR code for this. Essentially, for all the agents that we mentioned about, so first, we're looking at market pulse agents, right? Essentially, the agents will scan through 2,000 smart accounts, 30K sources, find all the relationship between each data point, and find patterns, as well as trying to understand the why behind each market movements. So over here, we can see we have all the top gainers and top losers. And besides just seeing the price movements, we can easily see the reason behind why the prices are moving. So let's say for Sky, I can know it has a buyback program. For Ethereum, I can also see the news. And if I'm interested, I can also click into the coin and see the details of what the agent has found. So over here, I can have TLDR and categories. And this is an example of agents taking the data, make synthesis, and then service opportunity to the users. And if you're interested in what the smart accounts are talking about Ethereum, we can also go to the X Mindshare agent. Essentially, this agent will take in all the smart accounts on Twitter, figure out the sentiment analysis, calculate the mindshare, and also correlate with the price. So over here, you can also see all the smart accounts that we're tracking, as well as the engagement, the smart account itself, and you can also deep dive or go to the original source if you like. So once I'm interested into Ethereum as an example, now I want to make a trade. So we also have a deep dive agent that will gather all the quantitative data. So for the tech analysis that we're seeing here, it's calculating all the support and resistance, as well as the per snapshots. And we can also go to whale activity, which we're tracking the hyperliquid whales, as well as the Binance large limit orders on the order book. So this is an example end-to-end of how an agent goes from discovery, right? So understanding the news, understanding the tweets, to consideration, so showing you the technical details, and all the way to execution. So if I'm interested into execution, I can also say I want to buy ETH, and the agent will prepare the orders and show you the form for you to actually execute. And besides that, we also have agents with ability to do deep dive. So to make it really fun, we also added ability to play podcasts. So if you're very busy, you can also go in and listen to the TLDR. So in the deep dive, you can see that it's doing in-depth analysis, looking at the time frame, looking at the table comparison, and you can also have key takeaways. And just on top of all the agents that we have done, we have also built a meme agent. So based on all the top trending lists on different meme launchpads, we aggregate the top moving, and also we score them, so we don't have to kind of click through different tabs. So as an example, for this useful coin, we can go in and we can see each different agent, token narrative, analyzing the narrative, momentum, market pulse, as well as safeguards. And if I'm interested, I can also go in, see the narrative analysis, like the social components, the markets, as well as safeguards. Yeah, so that's a high-level overview of what we have built with the agent architecture, and then the entire infrastructure will follow the principle of delegating tasks to the right agent, as well as tool pooling. So now we want to share the learnings to our fellow builders, exactly what we have learned developing these agents. I will go through lesson 1, and LJ will go through the rest of the lesson. So essentially, the lesson 1 is don't rush the LM development progression. So for step 1, you want to do prompt engineering as much as possible. Essentially, you want to baseline with the smartest model, and then tune the parameters, prompt, context, until you need to do fine-tuning. So for the smartest model, what we're looking at is you can tune system prompts, few-shot example, chain of thought reasoning. These are very easy tweaks, but then these can be fragile or unpredictable. Also, step 2, so once you have exhaust prompt engineering, you should move on to context engineering, so giving it the right information. So there's also progression for context engineering as well. You have key-value based, so very simple lookup. You can also do semantic retrieval, so looking at vector similarity, as well as knowledge graph, so you can map out an entity relation, or you can do hybrid, combining all approaches at once. And once you have done prompt engineering and context engineering, then you can go into step 3, which is LoRa fine-tuning. So for fine-tuning, you have 3 models. So the first one is SFT, which is pretty much teach domain language. You can think of SFT as just giving the model like Q&A, so like question and answer, and the model will essentially try to memorize that example. And for DPO, which is to align with your preferences. So a model itself is like really hard to know what is like a good like dad joke. But then if you tell it what a good joke looks like and what a bad joke looks like, then the model can now generate like decent jokes. So DPO is essentially giving good and bad examples. So now you have, and at the very end, you want to go with RFT, which is exactly what OpenAI themselves internally use for their reinforcement learning. So you can use the same model that OpenAI uses to train your own model to reason. Yeah, and so TLDR is do not go straight to fine tuning and kind of over optimize your model. Try to do prompt engineering, context, and then eventually we can do fine tuning at the very end. Yeah, pass it on to LJ. Yeah, okay.
Hey everyone, I'm LJ and I'm a founding developer in TrueNorth. And first thing at all, because later we are going to share more technical detailed lesson learned. So can I ask you like who is developer developing anything? Could you help me to raise your hand? Okay, maybe 10%. But I think the lesson learned is very important, and if you are not an engineer, in the future you may have a chance to vibe code. Now Cursor, Windsurf, Cloud Code is very fantastic, so I think this experience can also help you to build your own agent and to help you to automate your work. Okay, so many people want to build agent and they first think I need to learn an agent framework and start building, go to YouTube, search many courses, like they will introduce LangChain, LangGraph, AutoGen. But this approach is not so clear. If you want to build an agent, you need to first know what is the agent, what is the input, what is the output, and what you want the agent to do, what is the process. Agent now is not stronger than human, at least since now, maybe 1 or 2 years. So after you know what is exactly you want to do, actually you can use human to do it. And I think many failure pattern is some people like learn LangGraph and start to use LangGraph to build an agent, and then finally find out that the pattern is not feed their need. And this is because in the AI area, it is very new. So agent framework is very new. Like LangGraph maybe 2 years and small agent 1 year, AutoGen maybe 3 years, but you can see that this is not the MVC pattern in engineering. MVC is like maybe 10 years, 20 years of experience, and people know the best practice. But in agent, people don't know the best practice, and AI is evaluating so fast. So maybe sometimes ChatGPT have new model, and Claude have a new version, DeepSeek have new model. You will think the agent framework can fit your need. So at the end of the day, you will make a lot of work and it is useless. So we need to use first principle approach like a software engineer do. Like agentic AI is just large language model plus tool plus loop. So you can figure out it by your own and build it by yourself. And choose the framework only when you need it and only when it fits your need. Like you can add DAG or data pipeline to process data and to process the agent workflow. So the lesson learned is build with first principle and let a pattern emerge. Okay, and the next lesson is use boring tech for boring problem, and use AI for AI problem. And many people, when they first time see ChatGPT, they will say, whoa, this is fantastic, this can do everything for me. But actually, when they build an agent, they will find that the AI is not stable. It's because it's nature. And it cannot have domain expert level of knowledge. And if you use a long prompt to build an agent, want to see some specific outcome. And after, when you want to tune it to a more wider space, you will find it is very fragile. Like you change some word in the prompt and the output is totally different. And it is very hard to maintain. So when you build a small example, it is work. But when you build a large scale, maybe 10 use case, you will find out the agent is very worse and you're harder to fine tune it. And the cost and speed is also a big issue because large language model now is very costly. And I think for our lesson learned is we trying to use large language model to deal with anything, but we find out there is a better approach in specific area. Like when we do the keyword extraction, large language model can do a very great job, but after we try out, we can use also language model to help us to build a sophisticated regex system, like a rule-based system. When they see Bitcoin, when they see BTC, they do something, and it also have 91% of accuracy. So this means a lot because you don't need to have any cost and can do 91% accuracy at a system. And also, like someone may think like, if I build a very nice database, I can throw LM to let it read it to make a query. But actually, this is also a little bit fragile. You can warp as tool and make it as function call, but basically, engineering techniques still worth a lot. And also, many people find that LM, you can throw a question to it and it can get a much better answer. That's how you do it at ChatGPT, but actually ChatGPT is a fine-tuned version. So if you want to build an agent, you need to have the golden data set and synthesis. And sometimes large language model didn't very familiar with math and didn't do a great job. You can do the calculation, make it as a tool, and also make domain expert to engage in the workflow to fine-tune your agent. Okay, so the lesson 4 is you are the product manager and agent are your assistant. Many people think like, I have a task and I throw it to large language model, it can deal with me, but actually now the AI capability is not reach that threshold. So there are many failure modes like under specification and like ChatGPT 3.5 performance vary by 30% based on the prompt. So if you don't actually know like which node, the input output, and what kind of situation the AI agent will do, and you will possibly do a bad job and spend a lot of time to doing the useless fine-tuning. And so the lesson we find is we define clear objective and spec for each agent and set measurable success criteria like matches, benchmark. Later I will share more about how we manage the metrics and benchmark. And so also task-specific prompt also is very important, and you can engage domain expert to help tune the prompt with you. So I think the most lessons and learn of this section is actually now you don't let agent to do over human job, but you know each step and just let agent to help you to automation. And the lesson 5 is measure everything or fall slowly. So you need to iterate and need to have a clear direction to iterate. Many people do the agent, like when you check YouTube, they are like 30-minute builder trading agent, and actually you think this is the performance is very high, but it is not actually be through a scientific evaluation. So many people do agent and it will like vibe check, it seems work, but it is actually not work and will fail at some point. So when you need to build an agent, you need to define very clear metric. Later I will show how we do it, and before you building anything. And if the task you can track by the statistic like F1 score, accuracy, recall, so you can use the mathematical way. And if complex tasks like need to have semantic understanding or some domain expertise, you can use LLM as a judge. And so evaluation is very important because agent need to iterate so fast, and every iterate you need to make sure that it moves to the right direction and all the tasks is improving. Yes, so this is how we make benchmark. This is from Lance Smith, and we make thousands of tasks that every time we change the prompt of the agent, change the workflow of the agent, we run through the thousands of tasks and track the performance. Need to know that the performance actually improve. If not, and we will figure out like why this change is not work and change the change and iterate again. So this is very important because when you are making an agent, you will find that only change a small word, it will hugely change the outcome. So have a systematic measurement is very important. And also it is very important to have human in the loop. Like now, AI agent is not strong enough to beat human in some domain. So like crypto is keep evolving. So we have built like system to let the expert to score and to measure our agent's outcome or our data pipeline. So keep our data and our agent is on the right direction and generate nice output. And so thank you guys, and thank you for your precious time, and welcome to join us. This is the TrueNorth TBW workshop TG group, and join this group, and you can ask anything you want to ask. Anything you want to know can ask here. And if you want to try our fantastic agent, you can scan this QR code and register the whitelist and follow us on Twitter to keep in track to our latest update. So later on, if you have any problem or not, nevertheless for building agent or for the domain expert, please find us.
Yeah, so we have 44,000 currently in line, if you join today, we can help you skip the line and then have access to our beta products. Yeah. And also, we're also hiring. So if you're ever, you're students, you're graduating, we just raised, hopefully closing millions really soon. If you want to work with us, you can speak Mandarin, English. We're very chill. If you need meditation, you can go to him. I like to vibe. Yeah. And come talk to us after the workshop as well. Thank you.